Hi, today we are looking at section 8.1, which deals with comparing and interpreting rates. So first we'll go over a couple definitions. So rate is a comparison of two amounts measured with different units. So for example, if you go fill up your vehicle fuel, you'll notice that there's a rate for how much you're paying per liter. So you have how many dollars per liter. So you have two different units there. So a unit rate is also a rate in which the numerical value of a second term is 1, which would be that previous example, because you're paying a certain amount of dollars per 1 liter. So first example, a 6-kilogram turkey from a grocery store costs about $18. At the butcher shop, they charge $1.75 per pound, which is cheaper and by how much? Okay, so what we want to do is figure out how much the turkey would be at the butcher shop. So first we need to convert our price flow. We know our price is $1.75 per pound, but our turkey's in kilograms. Or shouldn't we call this price? I should call this my unit price. So we have essentially $1.75 per 1 pound. But we need to convert this into kilograms. So when we do that, because pound is in our denominator here, it needs to go in our numerator here so they cancel out, which means kilograms goes down here. Now, key to this is knowing a conversion factor. 1 kilogram is equal to 2.2 pounds. So now these pounds cancel out. So we have our unit price is 1.75 times 2.2. So it works out to $3.85 per kilogram. So that's our unit price in dollars per kilogram. Now that we have that, we can figure out our actual price by taking our unit price and multiplying by the amount. So our unit price was $3.85. Per kilogram. We are multiplying by 6 kilograms. What you'll notice is this kilograms is a numerator, this one's in a denominator, so they'll cancel out. If we've done everything correctly, those units will cancel out and just give us dollars. So we have 385 times 6, which is $23.10. So we can see the store's cheaper because it was $18, but by how much? So we'll go 23.10 minus 18. So that gives us $5.10. So we could say the store is cheaper by $5.10. Now we can often find rates from the slopes of graphs because typically we have one unit on one axis and the other axis has a different unit. So when we do our rise over run, we're going to have one unit over a different unit. Now we want to find the speed for each segment of the following graph. Now typically we want to do speed in kilometers an hour. So we will have to do some adjustments to our time to convert to hours. So first segment, segment A, is a segment here, then we'll figure out B, C, and D. So we'll start with A. Our time for A was 30 minutes. But we want that in hours. So we need to multiply that by a conversion factor. So we know there's 60 minutes in 1 hour. We want minutes canceled out, so it needs to be in our denominator, while hours is in our numerator. So our minute, because this is numerator, this is denominator, those cancel out. So 30 times 1 hour divided by 60 gives us 0.5 hours. Now our slope in this case is our rise, which is our change in distance, over our run, which is our time. So in this case, for A, we went from 0 to 20. So we had a change in distance of 20 kilometers over 0.5 hours. Now, because it's kilometers over hours, that's going to give us our unit rate in kilometers an hour. So that would be 40 kilometers per hour. Okay, on to part B. Similar thing, except for now our time is 20 minutes. So we'll do the same converting as last time. So that would be multiplied by 1 hour, divided by 60 minutes. So that would be 1/3 of an hour, or 0.33 repeating. Our slope is going to be our rise over our run. Now we'll start our rise from where that segment starts. So we start at 20, ended at 50. So that's a change of 30. So 30 kilometers, 0.333 hours. So that works out to 90 kilometers per hour. Part C, our time is 20 minutes. We just calculated that up here, so we know that that is 0.333 hours. So our slope is our rise over our run. So we actually haven't increased any on our y value. So we have 0 kilometers over 0.333 hours. So that's 0 kilometers per hour. Part D, our time is, we start at 70, ended up 110. So if we subtract those, that gives us 40 minutes. We want to multiply that by 1 hour over 60 min. That gives us 2/3 of an hour, or 0.666 repeating hours. Now we'll calculate our slope. So our slope is our rise over our run. So we can see that we're at 50, we went down to 0, so we had a change of 50 kilometers. And that's over 0.666 hours. So that works out to 75 kilometers per hour.